So let's go on to how this network actually comes alive. So this is your VBON. There is a mechanism for this to be zero touch. We'll not delve into that right now. We'll understand how this architecture comes up, and the zero touch basically is a logical extension of what this architecture brings. So what comes up first in a network that is SD-WAN capable? Essentially, you want to bring up your vManage first, your NMS platform, because who is bringing up your network is your network admin. So the network admin's view of the network, design of his or her network is driven through the NMS. So you want the NMS to be up and running first. Using this NMS platform, we can then start provisioning the control plane. So the SD-WAN control plane essentially consists of two components instead of one: the orchestrator, the VBON, and the vSmart controllers itself. The NMS platform, once brought up, the control plane is what's provisioned next. Once a control plane is brought up, we can now start deploying the edge devices. These are the devices that actually scale. When we say it's a 6,000 node network, a 10,000 node network, it's basically these edge devices. So once your control fabric is up, that's when you want to start getting your I/O fabric up and running. So how does the control fabric come up? Each of these controllers, the vSmart, so there can be multiple of these, are programmed to actually call home to the VBON, and this is over DTLS. I won't delve into the details of the protocol itself, but there's a secure control plane channel that's established between the controller and the VBON. This connection is the only persistent connection to the VBON. Everything else, every other connection to the VBON is ephemeral. Why is this persistent? You'll see it's pretty logical. So what you have is the controllers and the NMS having this persistent connection to the VBON. Now the operator or the customer wants to deploy his branches, his sites. We ship these edge boxes to the sites. Each of these edge boxes now are programmed in the same way to go and talk to the orchestrator, the VBON. On connecting to the VBON informs the edge devices of who and where the controllers are and the NMS is. Once the vEdge grabs this information from the VBON, it no longer needs a persistent connection to the VBON. It tears this down and proceeds to connect to a subset of the controllers and the NMS platform. So far, so good. Again, the connection between the edge and the VBON is using DTLS. The connection between the edge and the controllers could be either DTLS or TLS.
So Vinay, the consumption of these services, is this hardware or is this virtualized?
Okay, so all of the components on this screen can be virtualized. The only hardware component that we actually offer are the edges as well, because that's where you want to control the compute, the specifications. So if the customer actually wants a hardware appliance residing at their branch offices or data centers, we have hardware components over here, but the rest of it can run on any hypervisor, KVM, ESXi, on the AWS cloud, or even on Azure. So essentially the NMS, the vSmart, and the vBond, the controllers and the management platform are all virtualized, running as software on any hypervisor. The edges may or may not be virtualized depending on your use case. You could run it on a hypervisor itself, or you could have a hardware appliance that Cisco provides.
Yeah, I have a question for you too. So when you started to describe the architecture, you started this with the control elements and specifically vManage being instantiated by a person,
yes.
right? Obviously, we have many customers,
yes.
So we can't expect that every single instantiation will be handled by a person. So how do we handle the provisioning aspect of those cloud components, degree of automation or things like that?
Okay, that's a good question. So all of the control plane components are spun up in-house by us for the customers. This is completely automated. It stitches into our ordering system, and essentially none of the customers have to actually bring the control plane up. All they have to do from their perspective is when these boxes are shipped to them, just go and plug it into the offices they want connectivity for. So that's it. From the customer's perspective, all of this is automated. Even the only aspect that isn't automated is powering these boxes up and plugging it into the internet. The configs, the overlay bring up where we call home to the vBond, all of this is an automated system. There is no intervention required by a network operator. The network operator comes into picture only once this whole network is up. Essentially, we want him to only be monitoring the system and making sure he can actually manage the system. You don't need to actually physically deploy the system.
So based on what you're describing, would it be fair to describe this control plane, this network management system that we handle for our customers as a fully managed or cloud delivered service?
True, it is. It's a managed cloud delivered service for the customer where the network operator could be the customer themselves or a service provider. It really doesn't matter who is viewing or managing the network. We have a hierarchical system where you could have a service provider managing multiple networks through the same NMS software component, or you could have each one of the customers hosting their own NMS software and monitoring it themselves. We abstract a lot of this system down onto the NMS, so the operator essentially doesn't need to know the underlying technology to actually even manage the network. They would essentially get a good view of the health and status of the network.
Yeah, I guess one of the kind of a key elements of SD-WAN, why people gravitate towards SD-WAN, is really that degree of simplification of the provisioning process, of the operational process. So we have all this awesome technology running under the hood, but as a customer, if you just want a simple system to deploy and manage, you don't have to get into the nitty-gritty details of how they all operate. I guess that's what kind of gives SD-WAN that edge over more traditional ways of deploying things.
Absolutely. So I'll recap the steps that we went over right now, and also double click on the fact that I said this all is zero touch in terms of the customer's perspective. So now that we know there's a call home server here called the vBond for a particular organization or particular customer, what we did in terms of a zero touch architecture story is just have another vBond in the network. We call it the ZTP server or the PNP Connect. So it's the plug and play connect or the zero touch provisioning server. This essentially is just another vBond. That's all it is. So what this means for the customer, and I'll recap the steps. 1, completely automated controller bring up. Done by Cisco. Number 2, we register the customer with PNP Connect or the ZTP server. What this is essentially is a VBond for VBonds. So you call home to this VBond, and this VBond tells you where your organization VBond resides. That's all this is. So it does the exact same function as the VBond would do in your local architecture. It's just a common VBond for all.
So the PNP Connect and the ZTP server, are they a service offered by Cisco for the customers?
Absolutely. So the PNP Connect is a service that Cisco offers to its customer. The ZTP server is also something that we manage as part of Cisco. A customer need not register on either of these. We could create an account for them. We could update it automatically through our manufacturing and ordering process to get this information ready on our custom VBond or ZTP PNP server. So what it essentially means is this is a VBond that manages other VBonds. It basically redirects you to other VBonds. It performs the same action in terms of what a VBond does in your local network. All it means is any SD-WAN device that's shipped out today into a customer network talks to this server to get to know where its actual VBond resides. So what essentially the ZTP or PNP server does is the operation of the VBond. It's a VBond for VBonds. The edge devices are shipped to the customer site, powered on, plugged into the internet. They're pre-programmed to always go to the PNP server, which is hosted by us. The PNP server then responds to the edge after authenticating it using a whitelist and certificate mechanism to redirect it to go to its organization VBond, after which we go over the steps we discussed before. Redirect and connect to VBond. The VBond provides information over ephemeral channel to the edge about the controllers and the NMS device in the network. The edge device then connects to the controllers. And by controllers, I mean the vSmart and the vManage. So essentially, we have 4 steps to bring up the control plane. Now the edges can all talk to the controllers and the NMS platform. Any questions so far?
I have a question for you. When you described in the previous slide, when you described how we started the evolution, right, and you described the principles on the individual Cisco routers, one assumption that we could have always made is that the control plane is always accessible on the device itself.
Yes.
So in this disaggregated model, where we have basically decoupled the layers,
yes.
And you also made a statement that internet cannot be trusted 100% of the time to be a lossless fabric,
yes.
right? So an extreme case of that is that it has 100% loss and it's completely lost.
Yes.
So how does this architecture cope with the situation where the entire control plane infrastructure is no longer functional?
Okay, so I'll split that in two parts. So the first half is, hey, this is split open into the internet. So what it means is even getting to the edge devices means getting past NAT boxes, firewalls, etc. So that's the additional functionality of the vBond. Essentially, if you're aware of what a stun server is, the vBond acts as a stun server apart from actually a redirection or call home device as well. So all the NAT translations that happen for circuits that are connected to the edge devices are visible to the vBond. Hence, the vBond is the only component that has to be publicly available. These NAT mappings are then provided to the controller, the NMS, and the edge device itself. Essentially, not only the edge, even the control plane could be residing in a private network. So any NAT translations that you need in order to get through the NAT box is provided by the vBond. This is also the reason why we always have a persistent connection from the controllers to the vBond in order to keep that NAT hole active at all times and have the NAT mapping be programmed on the vBond at all times, so that no matter when an edge device comes up, it knows how to get to the controller itself. The edge device, on the other hand, if it has a NAT box in front of it, the NAT mapping for the edge device would remain persistent because it has a persistent connection to the controller. So once it gets to the vBond, the NAT translations for the edges are propagated to the controller, and the NAT mapping for the controllers is propagated to the edges, and we can have a control plane channel that's brought up between the controller and the edge. So that's one that should answer the first question. The second question is, yes, you could have 100% lossy internet. We assume that you don't have it on day one. At some point, when the network was lossless or with minimal loss, this control plane has come up and has been active. What happens is exactly like what would have happened on a traditional router. If I actually yank the CPU module off the router, the RIB on the controller, when this system was active, is propagated to the edges. The edges store this table for a fixed amount of time, which could be a few days, few hours, depending on how you want to handle your network, how much of a flux your network is in. The operator could determine how long he wants to cache this table. So once this programming is done on the edges have all the information they need to actually switch packets over the network. They no longer need the controllers until and unless there's a new routing update. Hence, if you get into a situation where you lose all control plane connectivity, you're still safeguarded using the cache table that resides on the edges. We call it a graceful restart timer that kicks in, that essentially lets you run your network without loss of data plane connectivity for a fixed amount of time till you can restore your controller plane connectivity.
Sure. I guess you can see that as another one of those sort of advantages of SD-WAN, because in the traditional router, like you say, if you yank the module out, you're probably going to kill the router.
You're going to kill the router. So yes. So this will, and essentially because now you have distributed the architecture, these controllers can reside in different regions, different data centers, different clouds. So now you have a high level of true redundancy across a network as compared to a single box where it's a single point of failure. Physically, it's a single point of failure. Right now, physically, it's a distributed architecture, so you're going to get multiple levels of redundancy in an SD-WAN architecture as compared to a single box. So I have gone over to recap the control plane bring up. Now we can, I'll go over next. What I will go over next is the data plane bring up. But before that, I'll backtrack to your question where how do we actually authenticate these devices and get these controllers up? We do that, as I mentioned, using two steps or two principles. One is certificates. Second is whitelisting. So what this means is, for Viptela or Cisco SD-WAN, what we want to do is first make sure that the device itself, that could be the edge, the controller, the NMS, or even the VBON, the orchestrator, is actually a Cisco SD-WAN product. It's not a rogue device that's trying to mimic a box that is manufactured by Cisco. So you want to authenticate, are you Cisco? Second, are you from my organization? How we essentially do that, the are you from Cisco is done using certificates. What it means is we have a signed certificate pre-programmed on all the edge devices that we ship out to the customers. These are, we use a TPM chip, a physical chip that resides on these hardware boxes that holds a certificate that's signed by a trusted authority that certifies that these boxes are essentially actually Cisco boxes. So you have this certificate that's programmed here. The edge devices, when they talk to any of the controllers, present this certificate to the controller saying that, hey, can you authenticate me? The controller then looks at the certificate and certifies, hey, you are a Cisco box. Conversely, the controller also presents its certificate down to the edges. The edge also authenticates that the controller is actually the controller it should be connecting to. So there is a two-way authentication mechanism built into the system. Are you for my org? This is done using a combination of certificates and whitelisting. So each of these certificates that are installed on the controllers and the edges contain a serial number inside them. The serial number is what the network operator actually adds onto his NMS platform. The list of serial numbers that the NMS platform must contain for a particular organization is provided by us through manufacturing. So we know exactly which boxes are going to which customer. So we provide a signed file which can be uploaded to the NMS platform, which will then give a list of all devices that the network operator is going to see through the lifetime of this network.
So our entire network, we're making sure it's authenticated using certificates and giving the administrators a way to manage this using whitelists. Using
whitelisting, that's correct. So the whitelist is then programmed onto all the controllers through the NMS. That's an automated process as well. The other advantage of whitelisting is, hey, I've shipped these boxes. You want to hold on to these boxes. They're not actually reached their sites where they belong to. You don't want them to get into the network if somebody essentially runs away with them or it's residing in a staging facility. So the whitelisting provides more granularity in terms of which devices can actually get into the network and start participating in the network in the data plane itself.
So is the whitelisting only evident between the controllers or also between the V edges as well? The C edges?
So the whitelisting, so the control plane essentially resides between the controllers. So between vSmarts, between the edge and the vSmart, everyone and the vBond, because the vBond is a server, and between everyone and the NMS we manage.
So at no point do we build control plane relationships between edge devices.
Between edge devices. So all of these authentication mechanisms are on the control plane itself, which essentially reside between the control components and the edge and the control. So one endpoint of this connection has to be a controller. So if it could be between two vSmarts, a vSmart and a vBond, a vSmart and the NMS, any combination, but one end of it, the communication should terminate on a controller. And this is where the whitelisting and certificate authentication actually takes place for the control plane, secure control plane breakup. There is security that's there's a secure aspect of the data plane for edge-to-edge communication, but that uses IPsec, and we'll drill down into that next.
Okay. I guess when that authentication process does not succeed,
yes,
then the connection does not get established.
It does not get established. You're not let into the network if any of these fail. Either it's a rogue device that does not belong to Cisco, or it's a device that belongs to Cisco but not the network, or it belongs to Cisco and the network but is not actually currently wanted for participation in the data plane itself. So all of these considerations are taken into account for actually bringing a device into the network. All of this is automated, but it's secured. We make sure that no rogue device can actually get into your network. Because of whitelisting, we can even get a device out of the network really quickly. You realize one of the sites is compromised. All you have to do is click a single button on the NMS platform and say, hey, this guy's invalid. I don't trust this device anymore. I don't want it to participate in the control and data plane of my network, and the device is terminated.